recording again. Yeah, this is Coffee Compiler Club. Anything and everything to do with compilers, language runtimes, garbage collection, concurrency, typing systems, language implementations in general, tools, VI versus Emacs. We don't have to go there, but we can. Build systems and the like. It's all being recorded live. It shows up on YouTube within a day, hopefully. If you're not good with being recorded, bail out now and watch it. I ask you to mute your mic when you're not talking, so we don't have too many, dogs in the background. Otherwise, that's an open mic. I reserve the right to moderate. Never had to do it. It's all good. And here we are. It's fair game. I don't know. Sometimes I start with a little bit of progress, and mostly I cleaned up my Hindley-Milner prototype some more, threw a bunch more tests in. It seems solid, and I'm re-implementing the prototype in my main stuff right now, and that's going well. I missed one of the key bits of the prototype, the last implementation, and of course, second system effect, life get a lot simpler, and I have a much smaller code base and a much simpler implementation, and I know where I missed the key semantic bit that I'm going to get right, knock on plastic this go around. And I have to comment on Cameron's lovely background. I will note that it's inverted left from right.
Oh, really?
Oh, I have something else to say. See, this is my wife in progress here.
Yeah.
I have a shirt.
From our perspective, though, Cliff, the background looks the same as yours.
Oh, is it really?
Yeah.
It's left right inverted on mine. Wait,
yeah. Well, you get to see the mirror image
of myself.
That's more natural for humans to look in a mirror, but the rest of us.
You're saying
I'm looking in the background. I don't see any differences. The light might be a little brighter.
No, that's not of course, the difference is his a photo, mine's live, so my cat will come across here shortly.
Oh yeah, I saw you open the patio door earlier, but
yeah, I'll open my door now. Cameron can't open his door.
It's a time lapse thing.
Yeah,
I've got a different connection.
Absolutely. I think it's in general true that you have a different connection, but okay.
Well, you got tired of penguins, right?
Yeah, and it beats the glowing mushroom head thing, so it's all good. That was just a little on the freaky side. All right, somebody start something. We ended last time with a bunch of stuff was rolling along. Oh, I know. Here we go. Simon, where are you here? You had a thing you wanted to ask.
Yeah, I was wondering I watched some of the topics, but not all of them. I was wondering whether there was like the grand discussion yet on different ways of dealing with equality and identity, especially when you have a look at like reference equality and the various ways you can deal with floating point values.
Oh, yeah, I think I have an easy answer, but I think a lot of people would necessarily disagree. So we might get a good conversation going here.
Okay,
so,
because sorry.
My easy answer is there needs to be an extremely simple fast bit test available to you somehow. I use such tests all the time to make high performance operations work. And so bit equality means if an x86 does +0 and -0 is equal, I don't care. That one's okay because I want super fast. But as soon as you go to semantic equality, I need one that says its pointer equals as the test, right? Now, having said that, as soon as you come to that one, there's another version which says I have some semantic equality test, which I use every time when I do a hash table. I'm trying to declare two things semantically equal, but they're not, like interning a string, right? How do you intern a string? Well, you claim semantic equal based on contents. Now you need a content equality, which I'm kind of leery about providing a default one that does something stupid unless it's truly stupid, which would be, walk the structures and demand equals everywhere. Otherwise, you write your own. And so you need to have a nice way to override you know, what the semantic equality check is, but keep it separate, semantic equality from bit equality. And the bit equality needs to be stupid, obvious, and fast.
Yeah. Yeah, as for instance, looking at languages like Haskell and Rust, they have these sometimes a bit elaborate type class hierarchies. And the one problem I found with that approach is that they, at least Rust, brought this partial equality and this equality trait into like an subtyping relationship. So for floating point values, you are basically forced to like either pick like the total ordering to implement both traits, or pick the partial ordering, and then you're only able to implement the partial ordering, the partial equality trait.
So floating point has the funny property that it's computer math, not real math. And so you pick up round off error all the time. So asking if, you know, 1.23456 is equal to 1.23456 is generally not what you want to do. You actually want to do a delta or an epsilon test. Now, having said that, I did a lot of machine learning algorithms, and so you always do these epsilon test things. Okay, having said that, you generally want to have control over what that epsilon is. And so in my mind, it doesn't make a lot of sense to throw it into a subtyping as or a trait or a mix-in at each point where I say, I want to know if two floating point things are equal. What I really want to say is they're close enough within some epsilon. What's the epsilon? Well, the epsilon varies by application.
I would generally agree on that, but I have like one bit where I say, okay, this is like my benchmark for like language usability, and this is like the having a list with not a number in it, and then asking, does this list contain not a number? And like this, like 30 or 40% of the languages which like manage to get the answer right for various reasons, like Java and C#, etc. And then you have like the other group of languages like Rust and Haskell and Python, who like gets the wrong answer, and I call it wrong answer because
what do you consider the right answer?
Exactly, it's like not a number is a list with not a number is contained within a list of not a number, and simply arguing from like if you will have to go into language spec lawyering to like argue why it can return false is like it's like nothing which should be exposed to a user.
So wait, but I didn't get your answer. What if I have two values, each is not a number, and I compare them, should they be equal or not?
That depends. So I think the thing Cliff mentioned, that you should have two different kind of operations. I think that's really the right direction. And recently I went with this approach a bit further and said, okay, I have like two completely different type classes, one called identity, one called equality. Identity uses like a triple equals and is derived automatically for reference types, and is bitwise equality for structs or primitive types, whatever you call it. And then you have like the equality type class, which has like a double equals, and you can just implement it any way you want. And having these two completely separate basically allows you to ask the question you care about. So you can, for instance, say, okay, I have this list type and I implement a method contains, which has a constraint that like the type of the element inside the list needs to be equal, needs to have equality. And then I can have like a completely different method. For instance, list has, which just says, okay, the element I'm checking needs to implement identity. So if I want to check, does like, if I'm interested in, does this list of not a number contain not a number, I can ask like, some lists has not a number, and I know it's only doing a bitwise equality check and nothing else. And I found this
because in JavaScript we already have 3 different equalities defined by the language.
JavaScript blew it.
And they're
Yeah.
threatening to add a fourth one, if I remember
Mm.
correctly. So, so what that means is that every data structure that does anything with equality by a method like contains or has in your example is going to have 4 methods for every method. So we could call them contains 1, contains 2, contains 3, and contains 4, right?
In what sense would this
Well, you have bitwise equality and virtual type equality and some
Triple equals.
Yeah, you have different
Variant.
forms of equals,
Yeah.
right?
Yeah.
So
Contains or not accordingly.
I mean, in your example,
Cameron, your sound just cut off.
sorry, that's the
Fiddling with your mute.
I'm fiddling with my mute. I got caught fiddling with my mute on Zoom.
Yeah. Okay, editorial comment for people who are new, check the chat. There's a bazillion links and comments already.
Yeah, I want to weigh in there, like not a number, but definitely an infinity, a positive infinity make floats quite painful to deal with. But I would say sort of a recurring issue with a lot of, I would say, established languages that provide equality for floats is that the behavior is essentially loosely or unspecified. And so you get these cases where if you compare, 1.2 with 1.2, it will work just fine. And people think, oh, great. And then they start comparing 0 points, a whole bunch of digits with, the same thing, and only, let's say, the last digit differs, and it will say, no, that's different.
You got D-norm.
And that's where you have this concept like unit in the last place. Or OP.
OP, yeah.
Which is what I'm using, for example, in my language, like float equality is defined as 2 floats are within 2 OPs of each other.
2 OPs of each other.
I picked that number arbitrarily, and it's currently hard-coded. It probably have to change it at some point.
Yeah.
And maybe add an option where you can say, hey, I want to float equality, but with a custom OP.
Yeah, and then like I was saying.
So we'll need list contains then that takes a number of OPs.
Right. So as soon as you said I have not bitwise equality check, you have a threshold of equality, and I claim that's very application dependent. Whether you want to be 1 or 2 OPs.
There was a
of course.
There's a brilliant article years ago, a guy writing about Excel and how Excel does math. Because I don't know if you know this, but Excel does math using base 2 floating point, but it pretends it doesn't.
Yeah.
So it pretends it does decimal under the hood, but it doesn't.
Excel.
So he's going through this example where he shows, and I take this and I divide by this and I get this and it's perfect. And I multiply by this and it's perfect. And I divide by this and it's perfect. And then I divide whatever. He does one more of them and it's then way off, because what it is it's like it's a tiny error, it's a little bit bigger error, it's a little bit bigger, and at some point it becomes a big enough error that Excel's like, I can no longer guess that should be rounded to 4 digits or whatever.
Yeah. Excel preceded IEEE standard. Intel started doing floating point when IEEE, who was the con fellow?
So I think Intel did their 80-bit when the 754 was still in development.
Yeah.
So it hadn't been finished yet. So Intel built, instead of building a power of 2 base floating point number, they did an 80-bit, which forced IEEE then to somehow bake that backwards into the standard.
But they had enough extra bits that they weren't going to have this problem. They had 64 mantissa bits and a exponent.
Well, if you go back to the 8086, and even I think before that, they actually had support for 2 different types of decimals in the assembly. There was packed decimal.
Not 2 different kinds. Well, they have ABCD or whatever, the name instruction for doing BCD rounding.
Well, but they had packed and unpacked operations. So you had packed multiply and unpacked multiply.
Those instructions were multiply and they were not. They were data structure representation in memory, maybe, but they were not. They were not
correct.
Semantically BCD. There was maybe there is a packed BCD in there now.
Well, it's register, multiply, add.
Yeah.
I can't remember all of them, and then there was
we are well down the rat hole.
But But I would argue base 2 floating point only exists in one place in the universe,
Yeah.
and that's inside human-made silicon. Like, that's the only place in the universe that the concept even exists. So I think it's a broken concept.
No. The issue is you need to have some kind of standard, and it needs to be fast and well understood so you can do numerically significant work with it, right? And then after that, it hardly matters.
I totally get it. And since we only have 2 kilobytes in our mainframe, and
Exactly.
only 80 columns on our punch card.
No. You're denying history here. You have real resource limitations, so the floating point had to be constrained to something realistic, both for size and memory for dealing with volume of data on smaller machines and size of silicon to do the implementation. Love it or hate it, I think Intel did a fine job. At the time, I thought it was a baroque both. But in hindsight, looking back, I think they did a fine job given the constraints of the time. Then we inherit those constraints. Now, rewrite every IEEE 74 piece of code on the planet. No, you're not going to do that. So here we are. That horse left that barn a long time ago. Live with it.
Yeah,
And
but
it's not a
IEEE
bad standard. It's
754
just
now has decimal standard as part of it, as of 2008.
Really?
Yeah, IEEE 754-208 is introduced. This is even worse. They introduced not one, but 2 formats for decimal encoding, because IBM had already implemented one, and then someone else had implemented another, so they just stuck them both in the standard.
Yeah, fine.
I think in the context of languages, at least with floats, the big problem is, as far as I know, at least, there isn't really like a sort of test suite that you can easily sort of use as a reference when implementing float equality or these different
You're very quiet.
Things. Sorry, hold on.
It's like, find the volume button on your mic. Blow us out.
Is this better?
Maybe.
I can hear you.
Maybe I'm going deaf.
Let me just double check. Yeah, it should be fine. Maybe I should just speak up a little bit.
There you go. Hey, that sounds better.
Oh, right. Zoom sometimes messes with the volume slider. No, I was saying that in the context of languages, I think recurring issue is that when you implement these floating point operations, whether it's equality or getting the absolute number, for example, for float, there aren't really any sort of standard tests or easy to access references that you can use to verify, hey, is my thing actually correct?
There are bazillions.
Well, as in, like, let's say a sort of simple format or a thing. To illustrate, I'm thinking case in Ruby, there was for many years a project called Ruby Spec. And the idea was to provide a set of tests written in Ruby following
so Matt's all over the chat with your test cases.
That's a bunch of links. Yeah, I should check that out. It might just be that I am not aware of it.
Yeah, JCK. I had the Java JCK, right? It's because there's a giant floating point section, and all those tests were inherited from somebody else, and they were just like found out every possible IEEE flavored thing on the planet, and all the evil corner cases for just exactly one alt left or right, and overflowed and underflowed, denorm. All those cases exist.
Yeah, well, today I learned, but I'm willing to bet at least that some of that information at least isn't, let's say, as obvious to everybody as it should be. And so you end up with these cases where, pick any 2 programming languages, and they probably do something different when it comes to, say, float equality or, converting a float to absolute numbers. Like there is, like libc has functions for it, but, let's say you, for whatever reason, can't use that. I'm looking at my own code here because I implemented it in my own language, and that doesn't have access to the function directly because I haven't exposed it. I can do that, but so I implemented it just through multiplication and subtraction, I believe.
No.
Which works in most cases, but not if you get basically enough digits. So for those cases, I think. those little differences in languages come from. Like I remember a blog post where somebody compared, I think it was float equality across like, let's say 10, 15 different programming languages.
Put that one in the chat. I'd like to see that. I certainly know that Java made the IEEE spec like to the dot by following the tests to the dot and doing what you had to do. And there were things you had to do that weren't too hard, but you had to do them. And then I spent a long time doing C2 compiler optimizations on the 8088. What are the Intel extra, not the SSE, but the prior version of floating point.
MMX.
Not MMX. What are the original ones? The ones that came out.
MMX was the original. That was the integer.
Was it MMX?
MMX. Yeah, it was.
Or whatever.
That had the CD.
Yeah, it had a stack. It was a stack-based architecture.
X87.
X87.
Well, that was the floating point.
Cameron has wisely erased it from his mind.
Oh, I didn't realize that's what he was asking. That was a coprocessor, the 8087.
Yes, that was the one I'm talking about.
Yeah, with F weight.
Yeah, exactly. I did a bunch of Java, targeted whatever C2 optimizations for Java to do hardware instructions. Those damn hardware instructions. Yeah,
that's the 80-bit FPU.
Oh yeah, I got you because I looked it up because I recorded Max. I recorded you last time, and you're all good. I eventually got the email mapping done. It's fine. Anyhow, I like the question of equality in general better than history of 8086 and IEEE. And I think we can agree that floating point is an issue that has to be dealt with, but there's a bitwise standard you can go track.
Yeah, that's what I ended up doing. It's basically I have like these separate traits. I avoid like at least a bit. I avoid this explosion of methods. Cameron pointed out rightfully by basically merging like the bitwise equality on primitive types with the comparison on reference types, and I also added comparable and sortable as two different traits. So sortable is to identity what comparable is to equality, and I have to say it from my experience it works really well, and it was interesting to me to figure out, it's like did anyone do this before, and it's like I've seen like some development into this direction, but I've never seen it spelled out in this detail or with like this kind of implementation approach.
By comparable, you mean it implements equality versus inequality only?
Less than and greater than.
Yeah.
And what's the difference between that and sortable?
It uses comparable uses the partial ordering as defined in the IEEE spec, and sortable uses the total ordering as defined on the IEEE spec. And the nice thing I forgot to mention the whole time is, of course, that except for like floating point values, identity and equality are the same for primitive types, more or less. So it's like you never have to worry about like, okay, I need to have like identity, but I have like this kind of generic type parameter, and it might not implement it because it's like only for floating points and stuff, but it's like it's available everywhere and it's like implemented consistently. And for most cases, identity and equality overlap. For instance, like for integers, there aren't two interesting comparison operations. So identity, equality are the same for integers, and sortable and comparable return the same thing for integers. And only there where it becomes interesting, they differ. So it's basically you can use sortable to implement like a tree set of floats without like losing values in there or missorting things, because like this thing is not a number and this thing is like a -0. And so basically all the internal operations work on sortable for correctness. But if you like want to ask, does this contain like 0.0, and with like equality means also like minus 0, sorry, minus 0.0, it still works correctly, because you don't get traits for free or type classes, but you explicitly have to tell, okay, this method requires identity, or this method requires equality, and from there on, everything works quite nicely, at least from my experience. So I'm quite happy with that.
No one else want to chime in on structural equality versus structural recursive versus pointers?
Yeah, I mean, I guess sort of way in how I did it. Like at least in my implementation, like regular equality is just double equals.
What is that? What is regular equality?
I always mix them up. That's the more expensive one, where it actually basically traverses the object. Is that
I would claim that the double equals should be the cheap one, cheap, stupid one. That's my theory.
right? In my case, that one's called same object with a question mark to make it extra clear. Like, hey, you are specifically asking, are these two things identical in memory?
Yeah.
I like how Java does this with double equals and dot equals.
Yeah, doubles equals is dumb, stupid, and dot equals is the complicated one.
This, yeah, I would imagine this depends on sort of the background that you're coming from. Like, I'm mostly coming from more high-level languages where usually double equals is value identity equality, I think it was, like the expensive one, and then usually like triple equals or something is reference equality.
Yeah, I think that's how JavaScript does it now.
Yeah, it's so in Ruby it's similar. Ruby actually does it a little more annoying. So double equals defaults for most objects to reference equality, but you can override it. And so some objects use identity equality for it. Triple equals is mostly used for switch statements. And usually the behavior is quite different. So if I remember correctly, if you have a range of say 1 to 10 and you do triple equals 5, it ends up saying, hey, is that 5 in the range of 1 to 10? This is what I remember correctly. You usually don't use it directly. And then I think reference equality, if I remember correctly, was used through a method called EQL ? So in somewhat typical fashion in Ruby, it's a little different, but yeah, it's, JavaScript, it's triple equals. I think PHP also uses triple equals, a couple of others.
Wow. I am firmly in the camp of double equals being dumb, stupid. Pointer compare reference equality is common and what I want almost always. And then rarely I care two things are equals after I check deep contents, but that's expensive and I don't want to do that all the time. So I have to ask for that one. And I have to have some special thing that says, I really want to have these two things to be equal, even though they're clearly different chunks of memory. And why do I have that kind of a situation? Usually because I'm about to intern you and then I won't have more than one of you.
Yeah, so I implemented it as somewhat similar to Ruby, as in double equals is equality. It defaults to reference equality as sort of the default implementation, because that's
you can't by the way say equality, because I don't know if you're talking about reference equality or memory content equality.
Right.
So you just
in this case, that
equality in this conversation unannotated. You gotta.
Yeah, so it defaults to reference equality, but you can override it and say, hey, I want identity equality instead.
Yeah. Okay.
And that way, I think you get what people want most of the time, which is reference equality. And only if you have, let's say you want to compare two arrays, then you probably want identity equality. And if not, you can still use same object, basically.
No, you need to ask for, here's 2 gigabyte arrays. Now, accidentally write, I want, identity equality. Oh, you're stuck spinning through 2 gigabyte arrays. No, Do reference
So-
equality until somebody says, yeah, okay, go deep. And as soon as they say go deep, they acknowledge they're going to be slow, and that's okay.
So do you think that Java did it the right way?
I think they mostly got it right. There are some stupid things, and Cameron's all over them. I don't want to steal his thunder. With like dot equals is not transitive, or it's not commutative, or whatever. Like if you do a dot equals b and b dot equals a, it's two virtual invocations of two different methods. So the dot equals thing is a little messy.
No, I meant for arrays that dot equals on arrays does reference equality.
Oh no, if I do equal, that's dumb, simple reference. If I do dot equals, I've already asked for the expensive version.
But not in Java.
We can
That's
we go arrays that there's arrays dot equals. You're talking about if I do dot equals with array objects directly? I don't know that they implement.
It doesn't. It does reference equality.
Yeah, that's what I was wondering, whether you think this was the right decision.
I think arrays dot equals does the deep version. I don't care. As soon as I said dot equals, I'm sort of in the zone of I have to make a decision about reference versus not, and I'll just pick the correct version for what I want, but I had to think about it. And I don't care how I spell it. Now, is dot equals on an array versus array dot equals as the capital A array dot equals? I don't care. I had to pick one. I had to choose to be reference or not. Okay, now I had to choose to spell it correctly. The choose to spell it correctly is like a trivial dumbass thing that I get out of my IDE.
Yeah,
So
the problem is it makes everything non-composable, because now if you want a generic data structure to use equals equals, you have to tell it, versus using dot equals versus using array dot equals, which there's actually no way to tell a generic data structure to use array dot equals, so you're fucked, right? So
no, you have to override the entire hierarchy to get. You have some structure that includes an array in the guts. That structure has to know that the array is called with the correct equals flavor.
Right, but I don't want a structure. I just want an array.
I'm sorry, if you have an array, oh, you
I'm
want
to put an array
hand an array off to like a hash table or a lookup mechanism and tell that mechanism, and also compare these things using, I have to override, I can't override arrays that equals. That's true.
So now I have to override HashTable.
Yeah, that's uglier. Yeah, okay.
Right? We're getting ugly quickly.
That's messed up. I like equal.
That's an area where I think Java could have. Right, that's an area where I think Java could have done better. Right, is the collections hierarchy framework, like HashMap, should take in something equivalent to a comparator for comparing the keys, right? The equalizer, right, so that you can fix it without having to extend or rewrite HashMap. That always bugs me with concurrent HashMap, for instance. I always want a weak concurrent HashMap, and if it had just taken in something to let me define what equality meant, I could do that. Or it's the I want an identity-based concurrent HashMap.
I have a version of HashMap that does identities.
Right, but the problem is that you had to have a version of HashMap to do that, and it should have just been HashMap took a function that lets you define the equality.
Yep. Well, it's because dot equals didn't what we want, because you can't overwrite it everywhere. Okay, yeah, so fair enough. So I'll claim Java dot equals was not what I want. That was a thing I hadn't thought about much. Like I said, I thought about equals, and then I didn't care what dot equals was, but I'll agree that's kind of ugly. Not allowing -x, I totally allow -x.
No, so I did that precisely because of these parsing precedence issues, but also because I simply didn't want to allow, I think they call it unary
operators.
Yeah.
I do unary operators for my parser. And I do -1 is implemented as one being called by the negate operator, not the negate operator.
Yeah, so I just not do it. Because you get this thing, especially with method chains, for example, you have like, minus foo.bar. It's like, okay, is it minus foo and then send bar to that? Or are you negating,
what's your unary operator precedence? So replace minus with bang for not, right? So now you say, bang foo dot bar. Whoops, here it goes in the chat. What's the precedence?
No, so
Yeah,
actually,
there's-
I solved that problem by not doing unary operators at all, and regular operators, the binary ones, they're all left associative, similar to Smalltalk. So you don't have to keep these
Yeah, Simon,
sort of
that's
lookup tables where you're like, oh, if I do multiplication first and then division, it's this, and otherwise it's that, and it's all left associative.
I also try to throw it out, because if you count it, it's basically, yeah, you have like the tilde, you have the bang, you have the minus, and that's pretty much it. You have basically three operators, and you're basically inventing like this whole conceptual language thing around it. And it's like, well, no, let's just not do that. It's like easier.
I managed to bake it down to not too much effort, but I did a different thing that made the unary operators like easier, and that is I have a table of operators that I look at the start of the parser, and he digests the table and builds the precedence ordering and all kinds of like left to right and in to out. And he sets up all these cute little tables to help him his life. And then I do a standard recursive set parser. He just looks at the table when he pulls that token out, and it tells him you're a left or you're a right associative, and you're higher or lower precedence and whatever else. But I can fiddle with my precedences and my ordering sort of trivially now. Oh, Starship and a postfix. Yeah.
What's a postfix?
I do postfix operators too.
Operator at the end.
So
Yeah. I also do split operators where you're like
this
two
happened
parts,
to me
square brackets stuff.
because the language I was introduced before C, the Waterloo Systems language, the dereference operator was a postfix. They used at instead of star.
Oh yeah, fourth
Same
line.
thing. You don't need two operators to do field selection, one with the dereference and one without.
Yeah. Fourth is a explicit dereference step with the at sign. Whenever that came, history there. That's fine. My first programming language implement was fourth, and that was early high school. It was a long ass time ago. That looks very similar to fourth. Not quite, but close. You put a variable on a stack, that puts the address of the variable. The at sign was the fetch. So at was fetch contents variable A, and bang was store. Value variable bang. I'm not claiming you love the syntax or not. I'm claiming it was 60s era and it worked, and it was cheap and small and efficient, and you could write code in it. But it wasn't the nicest syntax on the planet. And this is,
yeah, I think going back to the equality question with the floats, and which ties in tightly here, it's really about what you want your language to be able to surface, right? Do you want to be able to surface the address of something either directly or indirectly, right? So when you have equality, if it's specifically like pointer equality, bitwise pointer equality, what it's doing behind the scenes by making that choice to support that feature is it's saying I can't have two copies of this thing, even if it's immutable, because it won't be pointer equals, for example.
You can certainly have two copies. They're just not pointer equals. They're dot equals, but not pointer equals.
Right. So you take that optimization away from the runtime. So now you can't have a concurrent garbage collection that relies on splitting out immutable objects into
Well,
their
you
own.
can, because I've done such things, but that's independent. So
Right, but I mean,
the as if rule applies. You can make all kinds of shit fly here.
Right. Go back to the JRocket optimization for immutables, where they would run it concurrently with execution, because they would copy compact without stopping the VM.
They weren't the first people to propose various kinds of copy compaction operations where immutables were given special treatment, and you could hide the immutable pointer hack. You had two copies in memory for a while, and they had two different pointers, but the equality check had to do a thing if it was an immutable equality check, which is basically you did a read barrier and you were done. That those concepts have been around a while for a while. I'm not claiming we should go there, and it's a good thing not to claim that, and so on and so forth. I personally implement immutables myself every time I need them, because it's not a thing I need hugely, but when I need it badly. So now your claim is you want to provide that as a feature to the user, but I claim immutability.
Well, I'm saying it should be a conscious choice. I don't think any of these are wrong answers. But it has to hang together in total. I mean, that's the thing about design.
Yes.
Because you don't want you don't want to be running along and have someone hit you in the shins with a 2x4. So the idea behind behind design is you want consistency, so that it's I think it's Rebecca Worth that calls it the principle of least surprise or something.
Yeah, totally. That's one of my. But what surprises me and what doesn't is different from what surprises other people. But yeah, I totally get that.
Where can I get a background of your living room so I can also join this party? I just noticed you have the same background.
So you have to get on early, like Cameron did, and tell me to get out of the picture so he could take his own.
What are you talking about? I'm sitting here right next to. Oh, I gotta let the cat in. It's this side, right?
Oh, nice. Okay. Zoom just asked me if I'm playing music because I'm laughing. He's now telling me to set up professional audio and audio settings. Go away, Zoom. What the hell? Wow.
Hi guys. Let me maybe ask the next question. So I was just wondering in general, what do you think will be driving the future compiler optimizations? Just all sorts are welcome. Everything like accepted. What's on your mind, guys?
Mostly, what I see is that 90% of what we already know for compiler optimizations never gets implemented because it's too hard. So there's no point in inventing new ones because the old ones that are really useful are still like hanging out there. I stared at LLVM with Julia the last 2 months, and they're missing all kinds of cool optimizations. And LLVM is supposed to be the state-of-the-art thing. Well, hell, C2 Hotspot's beating it by forever and a day by 20 years of doing shit that was old 20 years ago. And I'm like, dudes, get on the stick. What the hell?
I think a good optimization there will be a book that explains these things in language that you can understand without being called cliff click. Or having 10 years of academic background, because I have a couple of compiler books, and some of them were highly rated, and some of them were specifically advertised as being more practical, focusing more on how to actually build stuff. And I went through them, and it's just walls of text, very boring to read, like basically no examples, hand waving stuff, left and right. It's like I just spent 80 euros on a book, and it's useless.
Waste of time.
But Yorick, important question. Did they spend at least half the book on parser theory?
Yes.
Right.
So I have
Okay, if I were
I would say both of them are 800 pages big, and at least a third is parsers.
Yeah, right.
And then there's a bit about attribute grammars, but it never really explains where you would actually use those and why. As far as I know, nobody really uses them.
Yeah, right. Cool concept from the 60s. It never went anywhere. Stop now.
Right. And then there's like, in one of them at least, there's like literally like 2 or 3 pages on type checking. And it's basically sort of high level overview of what type checking is. It doesn't explain anything. And I bought that book specifically because I was curious what ID.
That's one of those. That's Munchkin. Muchnick.
Let me.
Is it a new version? Probably is.
Yeah, sure. I mean, I read this book and a bunch of others as well. But so Cliff, you mentioned so some missing optimization. So can you give an example of anything that's missing that LVM is missing? If LVM is missing something, then probably we should fix it then.
So the thing that Java did that Julia does not is Java has a runtime. So the concept of a runtime here means I can profile. Now I can do profile guided optimizations. I can recompile and compile in the background so I can overlap compilation and execution.
Yep.
I can have JITted code call JITted code directly with the best possible JITted to JITted path. All these things like LLVM is just plain old missing. So if I run
I would say probably this is the feature of managed languages. So it's really it will be really hard to do in C++.
This is Java comes really close to C++, except where it wins. Like the two are neck and neck, and different kinds of things. One will win over the other, because you do get profile optimizations in Java all the freaking time, and they are valuable. And in C++, you have to try really hard to get them, and you only get them sort of pre-done in a what you hope is what your actual runtime turns into. So I claim Java's neck and neck with C++, and LLVM is not there because it.
One important point, though, and that is central to LLVM, and why is it written in the native language? Interoperability. You have to be able to call LLVM from C# compiler for burst. You have to be able to call LLVM from database written in C++. You have to be able to call LLVM from a C runtime on a microcontroller. And that's the only native languages give you interoperability across different runtimes.
This is not a requirement to not have a runtime or not have support for runtime. I don't have a way to tell LLVM, here is a low frequency branch. Should it fail, implement it as a load instruction that should it fail with null pointer exception, treat it as a low frequency branch to this target. Java does it all the time. All your null pointer checks are us, right? They all fall into whatever memory op you're gonna do anyhow, just becomes a standard memory op without a null pointer check in the generated code. I don't have a way to tell LLVM, here is a profile of the semantic execution of Julia code. I don't have a way to have LLVM tell me, and here is a stack crawl that can be done in a microsecond of limited depth then, that you can go reliably do, and I can collect profiles with under 1% performance.
So is what you're saying is that LLVM doesn't give you a good way to write hotspot? I'm
telling LLVM does not have baked-in support for a runtime that would let you do a hotspot-like thing. It has nothing to do with Java or Julia per se. So you ask, what is the future direction here? I think the correct future direction is integrating a runtime and a compiler to get the best of both worlds. It was done once for Java 20 years ago. Fuck it, why has it not been done again?
I think,
having said that, I might take some money in the next 6 months to go fix that problem.
I think that's where newer languages with JITs that looked at LLVM, I remember at least some of them were considering not using LLVM, or at least the decision was difficult because it had I would say, rather specific focus. Mm-hmm. And that focus seems to steer more towards ahead-of-time compilation and mm-hmm. less towards just-in-time compilation.
It's a really slow compiler too, at least compared by hotspot standards, is a slow compiler.
And I don't remember which recent-ish language it was, but it's, for example, where I personally haven't done any JIT because, well, one, I look at LLVM and I basically just poop my pants because it's a big project, complex, etc.
Yeah.
And the second one, mostly my experience maintaining a programming language that did use it. This is largely the fault of Linux distributions, but part also LLVM is that every distribution has a different version. Some of them are like 5 versions behind. LLVM doesn't really do any semantic versioning. So you have version 3, they have JIT API or whatever. Version 4, completely different API. I think though now that has stabilized a bit. And it's basically just
SSA book. Yeah. Okay.
And there's it basically ends up that all these projects, let's say Rust, they have to fork LLVM and distribute it themselves. And it's just something I don't want to deal with. So I'm kind of hopeful in Rust. There's at least a project called Crane Lift. Yeah. They are working on a just-in-time compilation library. It's largely targeting WebAssembly.
Yeah, they're a ways off. They got some time to go.
Yeah. It's like right now, like it doesn't do optimizations and stuff. It's basically like a basic code generator and an IR. But what I like is that or at least what I like to believe is that because they're focusing on WebAssembly, which runs in the browser, they cannot really permit themselves this to be slow. because it would affect users.
They kind of want to beat JavaScript, but I don't claim that's a high bar. But maybe it is.
Well, they want fast. Put it this way: they want to have a balance between fast JIT compilation and code that's good enough.
Yeah.
Right?
Yeah.
And
well,
that's I think what is sorely missing.
Code that's good enough with JavaScript has to do with the programming model and nothing to do with the JITting. That you cannot make JavaScript run fast because it doesn't have any types.
Well, they did. Have you looked at V8? It is pretty impressive.
Yes, it's very impressive. It's also slower than Java by a significant amount, and it's never going to play the catch up on the last bit. It's
pretty competitive in a lot of places, and in some it's faster.
Okay, I know. Last several times I checked, and I checked pretty hard, not more than a year ago, because I did a big damn ass web project.
Well, it's a lot of the same people.
Cliff?
Okay, hang on. I know some of the people that were in V8, but I don't know all of them.
Hello?
Jen, I think you were trying to say something?
Yeah, Cliff, do you know that V8 has very similar intermediate representation of C2?
Yeah.
They basically copied the C of nodes concept to their latest.
A bunch of people have. No problem. That's not what I'm saying. It's not the JITting process.
No, I'm not saying that it's a problem. I'm saying that I believe the C of node design fit this kind of dynamic programming language.
A lot of them worked at Sun figuring out for years what Cliff had built. So it wasn't surprising when Google hired them to write V8 at Google that they took that with them, because that's why they were hired.
Yeah, right. Not a problem. I'm saying something different. I'm saying the language model of JavaScript does not allow a bunch of core optimizations that you get out of Java. And so you have to insert runtime tests every which way to Sunday that Java does not have to deal with. Correct. And those tests just take time.
I think that comes down to, fast enough, basically.
Yeah, no, I'm not saying it's not fast enough. It's clearly hugely better than it was, decades ago. It's all good.
Right. I would normally say, people wouldn't use JavaScript 4, but in these days, the answer is probably they do. Because you have JavaScript on embedded devices and all sorts of things.
Yeah, my failure with JavaScript was had to do with memory models of large data structures, which I couldn't hold in the browser memory conveniently. So I'm doing, fintech data surfing with million points of data, and JavaScript is choking on that. And of course, Java had no issue.
Right, but so in the context of JIT, for example, when I say fast enough, obviously it's a balance. But let's say you can have a JIT library that does, let's say, or needs, let's say, 30% the complexity of, let's say, LLVM, just for comparison, and it gives you, let's say, 70% of the performance. To me, would be good enough, right?
Yeah, I claim C2 give you 100% of the performance and 10%, but maybe 15-20% of the complexity of LLVM, but 100% of performance. I think we can.
Right, you can definitely get
that. Frontier.
C2 has been around for what, 2.5 decades at this point.
It's been around a while. It's not as simple as it used to be, but it's not too bad. I've looked at the code even not that long ago.
I'd argue that the JIT performance itself, while it was tremendously important for C2 because of the gap it was filling at the time.
You're about to fall into my trap.
Sure, I'll fall into your trap. I'd argue that it's not terribly important for the applications being developed today.
Yeah, so I'm working on a giant ass Julia program with LLVM, and first run times are 100-fold worse than second run times due to the JIT.
But that's a reason not to use the JIT on the front edge.
I don't have any option. The only code generation strategy Julia has is to run LLVM. And
okay, yes. Sorry. What I'm saying is that's Julia's fault. Because you stop that program and start it again, and you have the same behavior, and that's stupid. No. Why didn't it save off the code it generated the first time?
Back up. Bad assumption to begin with. So these guys are having a pile of Julia code that would be very horrible to have to go recompile, and you could do it and get a one-off compile, but they're generating code, Julia code, to do queries because it's a query language database replacement, right? They're generating code. That generated code has to get JITted. That's my startup time. The time to get the database framework up and running from a cold start is annoying, several minutes, like 5, 6. It's stupid. Like H2O will be up in a second, fraction of a second, several minutes. Okay, fine. Now I'm in an incremental REPL. And if I make an edit, they incrementally recompile the one piece of Julia code, and it's not too bad. But every query I run gets JITted. Those take 5 minutes for the first run of the query, 4 or 5, depends on the size. And then like 5 seconds for the second run. It's like 100-fold worse. It's usually bad, which turns into you have to have a reasonable speed jet to go into the mode of I'm doing code gen as part of my normal everyday experience.
Well, and not just normal every day in that particular case, it needs
But
to do it on every operation. Yeah.
There are a lot of scenarios where people do code gen. I did it all the time at H2O as well. You got hot inner loops. We're going to do auto parallelization. I took your code and I code genned it. Right, and I added deserializers and serializers and web wireline protocols. It was all code gen. So that strategy starts to fail if I get knocked out, if I have 100-fold slower jet.
Did you see this paper from Hypergroup? I believe this is database, and they initially used LLVM for queries, and they immediately encountered the problem you encountered, which was the very, very high query latency. And the query latency was very, very high because the JIT latency for LLVM was very, very high. So what they did is just send it. It's the latest link in the chat. They implemented a fast bytecode interpreter for LLVM. So this is basically a tiering.
So badly here, I need a tiered compilation model.
Yeah, and that helped a lot. That helped a lot with the initial query latency.
I need to whack these guys on the head with probably this very thing.
I personally
that may be
still
one
wondering.
missing part in LLVM that we don't have yet. The very, very fast, low latency JIT.
Right. One of the fun things I'm debating now, if I want to go spend 2 years of my life, but would be make an open source version of a fast JIT with a fast runtime that was portable to multiple languages. That would be these guys they're well funded, have a cool idea, and they just ran against this hard wall. So we'll see.
I was going to say there, I'm still wondering why they're using Julia to write a database, but I would imagine that's a different discussion.
Yes, I have raised both of those points repeatedly and loudly, and they're sort of like stuck, and I'm still like, dudes, flip to Java, get all your code gen, speed compilation, blah, 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 issues go away. Julia versus Java in terms of like as a systems implementation language, they're not doing big chunks of floating point math operators like BLAS routines and stuff. That would be what I would think you'd be doing for Julia. They're doing essentially systems language. Who knows?
All right, so maybe a dumb question.
Yeah, fire away.
Why is package management in Java so painful? That's the only thing that stops me from using it time and time again.
That's easy. Welcome to DLL hell. It's only so bad because we've realized, because we had 1 million people use it for 20 years. You go back 20 years ago and it was an amazing thing compared to what you had prior to that. So history, you're stuck with it. Can we do better? Yeah, probably. I personally use a very simplistic version of the standard sort of package management things people do that I force to be simplistic just so I don't have these issues.
What do you like? You vendor everything, or you do some really stripped down like Maven, whatever?
I do a really stripped down Maven-ish thing. So my number one rule is thou shalt not touch the internet during any build cycle, because I will be on a 12-hour plane flight over the Atlantic with my Wi-Fi on so I can talk to my email. And if I let you touch the internet, you'll get 1 byte per second, 1 byte per second. And you'll go talk to Maven. Hey, do I have the latest version? And that'll take you a couple of kilobytes, and that will take me 30 minutes. So I have to turn my Wi-Fi off, which means I can't get my email. But 1 byte a second is fast enough for email. So the easy answer is my build never touches the internet. So I have to have a cached local copy of all libs. I use make because it's instantly quick and it doesn't screw up the way Gradle does. Gradle has a known big fail I'll rant on if you want. And I have one line in my make per library with the semantic version that I want. And the implementation says wget. So it goes to Maven, wgets, and smacks it down. And if I do a first time on an empty machine, I'll touch Maven. And if I do a please go touch my lives ask, it'll go touch Maven. And otherwise, it never, ever, ever touches the interwebs or Maven. And I have, like I said, one line per library that I care about. And that's my limit of what I'll do. But I also, to be fair, I do like system stuff, and I don't want free upgrades bring free bugs. So I don't take anyone else's free upgrades. I don't roll packages fast. I have a small count of packages.
Strategy public, because I feel like this is a solution that I would totally use. That's a great solution.
It's an AA. I've ranted about this plenty. It's an AA. Go to the top level of click on GitHub AA. Grab the make file. It's stupid. It's dumb make file. You roll down to the bottom. There'll be a make lib thing, and then there'll be some libraries here. I pulled up now. I can probably throw the relevant lines in chat. It'll just be ugly, but it's not. You're stuck with make syntax, and everyone's editor on the planet understands make syntax and deals with it. I like this line in my make file. It says here I want these things. I have a couple versions of lines that look like this, which say wget blah blah blah, right? One line per library, and there's my semantic versioning right there. And if I want to change it, I change the lib junit 412 jar to be 5.2 or whatever the version would be next, and I edit the one line there and the next line down, and I'm done. And then the next time I do a make, those libs will wander into my local directory and they'll be there.
I think Maven is a huge reason that it just hasn't kept pace with the rest of the ecosystem development. So all the backend stuff, like all the repository stuff, and that there's like Maven Central is amazing, but the Maven command line tool is just a really terrible interface. Like,
so tell me what you want out of dependencies. What is important to you about tracking and dealing with dependencies? I told you my importance. One line per version number somewhere in some common central place. No, never touching the internet during a build. Cannot, thou shalt not. It's kind of most.
I agree on that. It's in addition, I would probably have things like cross-compilation builds, so like build against multiple versions of a language or runtime, multiplied with like compile against JVM, compile against JavaScript, compile to native.
More complex systems, I do a more complex make setup. So like the hotspot at Azul, I had a much more complex build setup in order to get builds against various versions of things, but I'll just fail. Fine.
I personally, for personal projects, I ended up with SBT because I can't stand Maven for private stuff, and it has everything I need. And because Scala is so slow, they at least built a build tool that doesn't waste any time, because they really don't have any time to waste. And SBT is really nice. It's like better IntelliJ integration, like the whole client server thing is pretty nice. Incremental compilation, test runs is so much better, and the whole log file output is, it's like compared to Maven, where you have like pages of completely useless stuff. It's quite nice.
So a couple of things you said there that I have very straight up sort of careful opinions on. My make build setups only ever produce one line per file, or it's a bug, because I don't need to see the foaming madness of whatever your output is. However, if you have a giant production output, it has to go somewhere, so I tee it off into a log. And then I only get one file per file line in the make. This is where Gradle fails, because you only source of atomicity you have in a file system is the file system. So you have to name your files that you're going to touch and do atomic file stamp updates. So if you do any kind of concurrent parallel make, you have to have only the file system will give you atomicity. So the outputs that produce like spewing extra things, log files and whatever, I throw in a temp directory. If it passes the build step correctly, I take the one file I want and I move it to where I want it, and then I delete the temp. If it fails the build step, it stops and leaves the temp, and you have all your guts and you can go diagnose and debug. But if it passes, you get one line per line mention, and it's one line per, and make one line per line, more or less. And you get all the shortcuts that everyone does. That's all fine. But you want to not have like log file output just like spewing out, because you won't look at it. As soon as any one person spews log file output, everyone loses the ability to find something exciting in the log file. So I shall not allow, do not allow anyone to do foaming giant log file output.
No. Yeah, I think it's SBT is like one line for each successfully compiled module.
Yeah.
And of course, if there are test failures, it shows the test failures, but otherwise it's silent.
If you get right, I do the JUnit thing for the failures. The success is the dot for test, the little dot running long. And if it fails, of course, it spews, and that's all fine. And the test leaves whatever temp things in the failure around. That's fine. But if it passes, nothing. And that's been a thing that's sort of hard lesson learned in running software groups and teams of people and shit like that. As soon as any one person wants to spew log file output, everyone loses the ability to read the log file. So you cannot allow it to happen.
Yeah, I think there are like these command line tools which do nothing but filtering the output from Maven to something usable.
That I didn't know, but I can buy that, sure. I have certainly been in environments where I ran all my build steps through such a hand-rolled, filter because of all the shit that spewed out. You had to just delete it, or you never could tell. Oh, I passed or I failed. Well, 500 pages. I'm scrolling back through the edit buffer looking for the fail, searching for the word error. Well, the word error shows up 300 times when it's not an error, and you can't find the fails, right? It's just like, no, guys.
I found it. I posted in the chat. It's so funny. There's like a GIF on the front page, so it's some people might be happy.
Might be happy and might be offended. Let's see, Maven progress bar. Yeah, so I don't use Maven for builds. I mentioned already. Okay, fine. I use make because it's instant. And talks about the right kinds of things. Yeah. I don't have right now a big enough build to care for a progress bar. I have had it in the past. But the problem, of course, is that you get nested progress bars from different tools, and they don't actually nest. So I don't have a whole top level progress bar thing. So we did a lot of stuff at H2O about trying to give progress bars to large, complicated, like doing hyperparameter search over a whole lot of different algorithms that are on a whole lot of different data sets. Give me a progress bar for the overall thing. Turns out that's actually a hard problem. You have to go first have a short sort of constant time ask question where I ask, how long will this take? And of course, you only get an approximate answer. So sometimes my answer comes back in steps, and sometimes it comes in time, and sometimes it comes back in bytes. There's a couple different progress things. And then you had to convert them all to some uniform metric, and then convert them all to time. And then you added them all up and said, I think it's this. And so you put a bar up, and then you start walking it according to whatever things. But there was every piece that was supporting this had to have a fast, quick question they could answer about what they thought the progress would look like. So you could pre-ask recursively, large scale structure, bring back, sum up the answer, and then you could progress bar everybody. It was a big problem.
Yeah, it's extremely invasive to make progress bars work fine. It's basically you need to change. Basically, you basically have to look at everything. Okay, could this take more than 100 milliseconds? And if yes, there has to be like some parameter or some state you have to return.
Right. And then there's a lot of things. I had to have a kill it button based on time. So I could say I wanted to run until I made progress, or an hour went by, and then I wanted to just kill it.
And cancellation.
If engineers are bad at estimates, why are their programs going to be any better?
Exactly.
Yeah.
Exactly.
And even in cancellation, it's like try canceling HTTP request in the new modern Java HTTP implementation. It's like either you find like the Stack Overflow article about it, or you don't do it correctly.
Yep. H2O's big distributed scale out math platform doing machine learning. Now go cancel. Oh, I've got 100 nodes in a cluster that are each got a work list of 1 million operations on terabytes of data, and they're in the middle and they're on the fly. No, please, sir, cancel. Bad answers from partial results keep flowing back at you for the next 5 minutes while people peter off and discover that they're actually supposed to cancel. It's a really pain in the butt to get a clean cancel out.
It's reminds me a bit of like progress bars in notoriously
Windows,
where they're like, we're 50%. You're like, it's almost done. And it's like, we're now at 20%. You're like, wait, what?
Okay, just to be clear, I last night downloaded a game from Steam, and Steam did the same thing to me. Totally, it ran up to 100 megabytes a second download speed. We got 3, 2, 2, 2. It went blank. About 3 minutes, and then it bounced all over the map, and it took like 5 total.
Okay, which game?
I think I picked up Noida. It's a totally evil, stupid game. It's 2-dimensional particle physics to the max with a little, wizard dude who can move around kind of sort of in a highly, I want to say hostile environment, dangerous environment. So everything he shoots explodes or drips acid or, confusion. All the monsters blow each other up by accidentally shooting the environment, which totally melts and blurs and lava flows and freezing ice things and whatever. It's fun, and it's particle physics as a game. It's just kind of cool.
I missed the name at the beginning, Cliff. Can you write it in the chat for me?
Yeah. Just a second here.
There it is, of course, York.
Yes.
Google it.
Yeah, you beat me to it. Yeah, it's a stupid fun, but you get to die a lot while you figure out that it's actually really dangerous. Like the first fun thing to do is you shoot everything that looks shootable, and they explode, and all the lanterns drop flaming oil, and that catches fire, and then gunpowder goes off, and the vats of boiling sludge let loose their toxic whatever, and it's all cool, and you're flying around having a great time, and something dings you, and then you're on fire, and you land somewhere, and now you're covered in toxic sludge, and somebody's doing something else, and something falls on your head, and it's like, oh, ding, you died, try again.
I think that the Steam example is actually quite interesting from a progress bar point of view, because it's an example that like this progress bar stuff is like not a series of sequential steps, but for instance, Steam for some games it downloads and decompresses it concurrently, and for some cases it does it after each other, and I think that makes it even harder.
Well, you're parallel writing to disk as you're parallel polling in bytes that maybe go through some sort of decompression step. So this is kind of stuff we did at H12. We had many parallel steps, and there were sequential parts after the parallel parts, and in a tree of sequential parallel. Now go compute an early estimate, and now also support cancel, not operation. It is brutal.
I recall reading something a couple of years ago where some people looked into how users perceive progress bars, and they found that even just putting a progress bar that doesn't actually do anything, so it's like let's say 80% and just stays there, but it has some animation playing. That alone gives people the perception of progress and makes them less frustrated.
Yeah, they need to have the dancing, bikini girls with the sign saying "just a moment," dancing across the screen, and it's just there to distract you.
Or Clippy saying, "It looks like you're getting frustrated."
So
that's
when I started, that was really useful, because when things froze and hung, all of the work was being done on the UI thread. So if no progress was being made, the UI never got updated. It's less useful to me.
Yeah. Well, that was part of the whole UI learning experience. Oh, here it is now. XKCD. I missed the link. Yeah. Fine.
I feel that industry has been globalized very obviously. But when we're talking about software development, if you take a look at all different languages package management, everything has been globalized. You wrote a single individual contributor writes a package and push it, and every developer all over the world can pull it using like a Maven or something else. to get this. I came from China. It's very, very painful to involve this kind of Maven repositories all over the world because of the internet censorship. You cannot imagine how difficult for this kind of the experience was very dreadful. Why? Because our Chinese government, try to censorship everything, even the Python package, distribution package, even some kind of random Maven package. So
you could totally use Maven or NPM to do, subversive document moving.
Right. And every time there's an open IP, that's what happens. Yeah.
Yeah, I don't know why, but the censorship is not like a higher level. They
why is
they do
easy, dude.
Yeah, it's difficult to do.
Note to self: don't name open source project TM in Square.
Well, it depends on what your goal is.
Yeah, yes, exactly. So some people try to sabotage this kind of thing. They try to inject some kind of sensitive message in GitHub in some kind of important package, try to deliver their political goals. So that's why that makes things hard, because I'm not like that very enthusiastic about the political. I want to write code, but the other guys try to make things harder. This is funny, but don't know, maybe. So we need to develop more complex encryption things for the TCP level.
That's not
message
gonna save China from blocking GitHub because people be pushing political around.
Yeah, I feel that we need to develop some kind of a TCP or IP level, a packet level encryption to make sure that those censorship guys cannot understand what's going on. And
as soon as you go there, I mean, for every weapon, there's an anti-weapon, right? As soon as you claim I'm going to encrypt, the other side has the option to figure out how to decrypt, or simply like deny you, poison your bits so you can't decrypt it either. Anything else, right? Oh, you're sending something in code. Disallowed. House be an open, clear, so we can decide to censor or not. Right. You're asking for Maven, NPM, GitHub to try to work around Chinese censorship.
Yeah.
Actually working around it, which means they would be an enabler to doing political messaging in the Chinese environment, for which I don't agree with Chinese policies, but I can understand their position that says we're going to crush you like a dog because we can. And so, I think you're asking for.
Yeah, in the end of the
game
day,
never ends. I've seen malware that is using the Chrome bookmark syncing features as a command and control channel.
Yeah, right.
Like, it is this game of let me find something that is so important to your users that you're not going to block it because that would be annoying, and then you have to figure out how to block that without annoying your users. Like, this game doesn't end. It just has more routes.
Wait a minute. I feel that in the end of the day, antivirus software should win. We
would like it to win. We're just commenting that China as a virus or an antivirus, maybe it's an antivirus, the correlation is totally there, right? There's people who clearly do bad things, the virus guys, who are playing the game of trying to break your security, and you're playing the game of trying to tighten your security. Yeah, exactly. Shh. It's a never-ending cycle. Do you really want to get into it? Maybe you do. Not everyone. Understand other people don't want to. Understand other people don't want to deal. I myself run a very strange antiviral strategy, which has worked for 40 years, so I'm very pleased with it. And that's I shut down everything on Windows except the bare minimum and just kill everything. And then I don't run antivirus software because I never get it because I got no modern hooks. I'm a little
more extreme than that. I just don't run Windows.
Well, that works too. No, but if you run Mac, my wife has issues.
No, I've got Linux and I don't install things pretty much. That's
okay. So yes, so that would be a similar protocol as you don't install. I have to uninstall on Windows when a new version shows up, but that's sort of the limit of what I have to do. But I don't run a lot of these games. Like I don't run Chrome. Chrome had a different fail for me a long time ago, and failed hard badly in a lot of ways, including being unwilling to politely go away when I told it get the fuck off.
It only has one reason to exist.
I'm sorry?
Chrome only has one reason to exist.
Well, that's so Google can beat Microsoft over the head.
No, it's to spy on you.
Well, no, that's what Edge is for. But
No, that's what
right.
what Chrome is for. I know the guys who wrote it, and they told me that the reason they wrote it was to spy on you,
Yeah,
and track you.
Yeah, right. I'm with you. Yeah, Google makes our money from advertising, so there you go. So yeah, so I run Firefox, I run NoScript, I do all the right kind of things there.
Update to the latest Firefox. It has separate cookie jars for each domain.
And also I delete them as I close every tab. There's a bunch of things going on there at Firefox you can do. I have a handful of companies I let cookies live, and everyone else gets the old your cookie lives until I close the tab.
So back
I
to
just use
compiler
e-links, right? That's the only safe thing.
I'm sorry, what?
I just use e-links.
Yeah, I want a browser.
I'm joking. Nobody uses e-links seriously.
Isn't that Minx?
Yeah, links. Yeah, something. All right, stop.
I was going to say, like,
far away from compilers.
Coming back to like package management, I think what Sin said, part of it is everything is everywhere, but I think also part of it, a lot of it is built not with mirroring in mind, or let's say specifically not with bad internet connections in mind. So you get these projects where it's like, oh, you want to build a static website, install this thing. So you think, okay, you do that, and it installs like 500 packages.
I know.
And it's like, half a gigabyte of stuff, most of which are probably tests and documentation you don't care about.
Mm-hmm.
And it pulls it from like some S3 bucket in, God knows where.
Yep.
Well, we should also divide the problem domain up into, what does a developer face? What does someone who's building it face?
Yeah.
What does someone who's linking it, whatever that means, face? And what does someone who's running it face, right? It's like, and then there's also testing, right? Like that came up previously in terms of the combinations of versions you want to test and stuff like that.
Dev cycle is interesting. For the JavaScript NPM thing is both interesting and good and bad and ugly.
Yeah, I wonder if people in this group have opinions on, so the general consensus seems to be we should be pushing toward like more, get all of your dependencies, check your dependencies into the repo, produce a static binary, and just hand out this one object. But the thing that seems to have won is the browser, where you're like, go to this URL, I've given you one string, it will pull in a package that then pulls in more packages. Like, the web is the exact opposite of that. It's do all of the compile and all of the link and all of everything at runtime with dynamic code loading.
So there is a clear, a hard push from the capitalist market theory. If your web experience sucks, you quit using it. So websites that are slow to load, you quit bothering, right? So anytime that web experience gets too bad, you lose the monetary gain that the developer of the website would have. So they are motivated to make sure that it's tolerable. So as soon as I'm on the web, the 99% answer is I have some kind of decent web connection, but most of these packages also have built-in timeouts and lazy loads and parallel background and and things filter in one at a time. That's all driven by keeping your experience tolerable. If you're a developer, on the other hand, a fucking first NPM sit down to do a React Native app is like, I don't know how many gigabytes of code gets yanked in. It's unreal how many comes in. And of course, it's layers upon layers upon layers of dependencies, and every one of them's got little bugs, and you're constantly shuffling desired dependency levels to try to keep the bug tolerable. Like it all worked great until you did this thing that's supposed to work and it fails. It's like, oh, we know about this bug. You got to have this version of that thing, which needs this version of that thing, which conflicts with this version of this thing. You can't have both at the same time. Sorry, guys. And I've been down that path many times in the last couple of years doing web development. It's just like, what the hell is going on here that the disaster is this scale?
I would say that developers are basically should be limited by law in their internet speeds so that they are forced to deal with these kind of things. And it's similar to how in like browsers you can simulate bad connections. That should just be the default. Because I think part of the issue here is that, let's say my home internet connection, it's half a gigabit. I can download whatever, and it takes 2 seconds, and so it automatically becomes more difficult for me to remember, like, hey, wait a minute, if I put this thing out there, whatever it is, people might not
On my phone, and I'm
be
driving.
able to get it as fast as I used to.
Okay.
And this was for me very apparent. Like my mother, she lives, in a different country, Denmark, in the middle of nowhere, and I think up until 2 or 3 years ago.
Aarhus?
Sorry.
There's more than one city. There's more than one city in Denmark.
Yeah, but that's the middle of nowhere.
Yeah, I mean, outside of Copenhagen, it's basically middle of nowhere everywhere.
Malmo.
But so anyway, so up until like 2-3 years ago, her internet was DSL, but it was this very thin copper wire running somewhere across the building into the ground. I think max speed like 100 kilobytes per second. And I remember one Christmas, she had this issue where I think the version of macOS that she was running, it was no longer supported by Apple or something. And so it didn't get the automatic updates. And so I don't remember exactly what the context was, but I basically had to install a bunch of gigabytes of updates. And I couldn't get it done during Christmas because it just took too long. And she had to leave the thing running for like 2 or 3 days just to download all this stuff. And I was like, this is what we did in like the 90s with dial-up. Like my dad would have like a laptop running for like days on end to download a 10 megabyte MP3. Like,
my wife
what happened?
Updated her Mac OS last night, the night before, because there was some other bug going on, and that took a freaking long time on what I claim is a pretty damn state-of-the-art wireless Wi-Fi connection.
Yeah, and so now she has fiber, and now it's like, lightning fast. But of course now Apple decided, we just don't support this hardware anymore. So I think next Christmas I just need to bring a new computer entirely.
Yeah, and update it before you walk out of the Mac store.
Right.
Boot it and.
But so it's that whole thing. It's similar with hardware, where I remember there was a particular game developer. I don't remember which one, where there was this interview with them, and people were surprised that this person wasn't using top of the line graphics cards.
Oh yeah.
He had the same argument. He said, "Look, if I do that, then my game is going to be optimized according to that.
Yeah.
Whereas I want it to be optimized according to the average person."
Yeah. I have totally.
And that's kind of what you see with developers too, where, for example, they write their code in such a way that it looks great on their 50-inch display.
Works great on my machine. What's your problem?
Yeah, you tell, look, can you maybe format it a bit differently? It's like, what do you mean? Don't you use like a widescreen display?
You got an ASCII, Dvorak, using the weird Euro key, do you? No.
Right.
Yeah, of course.
That's also syntax, where some languages that put the symbols in, like, I think German keyboards are one of the main offenders here, where some of the keys are like less ideal places.
Those evil Unicode characters, shoot them all.
Come on, Simon.
Yeah, it's completely pointless. It's like I use personally like UK layout, and I mapped all the umlaut characters to caps lock. So A umlaut is basically caps lock A, and it works perfectly fine. I don't have to deal with it, and
You're not an
no. I'm more a nano guy.
I had this problem once. I was trying to build something and I needed a base 85 encoding, and I tried to answer the question, what are the 85 ASCII characters that are most typable by the most people with the most keyboards? That's not actually a trivial question to answer.
Yeah, there are reduced base something alphabets where you have like, instead of like having like 4 different base 64 encodings, you have like one base 58 encoding, where you then actually know, okay, this will survive as a URL, this will survive as like a file path, and so on and so on. And it's like crazy that we still haven't figured this out, basically.
All right. It's an hour and a half. We've wandered far down the path of Chinese censorship and bad keyboards and personalized keyboard choices that are questionable, especially backgrounds that are questionable. There you go. That's a questionable. There's your color choice, sir. You can have your keyboard any color you want as long as you want black. See, that's good. Excellent.
Yeah, before we go, can I ask a question?
Yeah,
in Java. So
Sorry,
basically,
sorry, hang on a second, Cameron, you have to know that there's a blue background filter thing happening. So it's not going right now, but when you went behind my exercise ball, there it goes. The exercise ball did a thing. Okay, fine. I'm sorry, Zen, carry on. Ask your question.
Yeah, I'm still working on the shallow copying of strings, right?
Yes.
So one reviewer raised a question, which raised a very legit question about my approach. He says that I need to make sure that the source of array copy must be stable or frozen, otherwise it's unsafe. Because if I do the shallow copy of after I eliminate the new array, allocate array of a string, I do the shallow copy, and so which means I make like a fake OOP of make a fork. Make sure that I point in the middle of original string, right? So I need to make sure that the original string is stable, or the original array of byte is stable. So I just want to ask, so how can I determine that array of byte is stable? So if there's some kind of effective way to do that.
Yeah. So you do what string does. Which
yes,
is,
I know string does. So Cliff. So I know string does. So that's why I hacked load node value. I hack this value, and I hack this value when I load a reference of the value array of byte. So I modify the type of it. I modify type to make sure mark that this array is stable. Then I run into another problem. What's the problem? So when I do the latex, because I by hacking in this way, I alter the code shape a little bit. So because I see that originally there's like a code shape like a check cast pp. One use of this is the first node is cast pp, and the use of the cast pp is some kind of addp, which try to load some kind of byte from this pointer. Originally, because the type of checked cast pp is consistent with cast pp, so the value can fold these two nodes into one because they are essentially the same, right? But now cast check cast pp is like an array of byte. But the cast pp, the type of cast pp is stable array of byte. So the type are different now. So how can I make sure that I still have the same code shape like before? So I have no idea.
Okay, so back up. So I heard you say I took the result of the load, and I declared it stable.
Yes.
That's I would claim that's an illegal cast unless you know from the shape involved that it can be stable. I have to make sure. So the first requirement here is you can't just declare something stable out of the blue. If I pass you an array of bytes and you wrap a string header around it, you're not a string no more. You're broken, because the array of bytes can be modified by somebody else, and then you're toast. So that's the reason string, when passed an array of bytes, makes a defensive copy.
That's why I call my code changes hacking. So let's get back up. So is there like an effective way to determine the array is stable or not?
No. Yes, there is, and no, there's not. The yes, there is what string does. It comes from a new. So the defensive copy is made. You have to track all the pointers to the object from its creation point. And if you ever lose track of it, it's not stable. All right, this is basic escape analysis. So string does it by making a defensive copy. In your case, if you have it all localized and inline, you can do the escape analysis and discover that no pointer escapes. But if somebody escapes that pointer and then publishes it, and another thread picks it up and then writes into you, you're broken. And that's exactly what the hackers try to do when they break security with string hacks. That was the whole string not final thing that went around in the Java memory model game. Not to mention censorship. Yeah, totally mention censorship. They can censor for censorship. No, that's funny. Okay, fine. And no, don't put the word censorship in the chat log. Yeah, right. Fine.
Just don't want to get anyone in trouble.
Yes, I'll get in all the trouble in the world here.
Not worried about you, Cliff.
Oh, good. Yeah, fine. Yeah, so you need to, before you can declare something stable, you have to do it by basically escape analysis. And you can do a trivial local one, and then your transformation only works on trivial local cases. But all the inlining's done, and you work your way, up the pointer edges to the new allocation site, and you track them all, and you discover you know where they all go, and none of them escape.
Wait a minute. Escape doesn't mean that this array is immutable. Even though this objects never escape out of this method, it still can be mutable, right? Because some code can modify the contents of it because it's array. It's not like a scalar.
You are handed a new, if you have the new in your method and you don't escape it, you can see all the uses. If there's no modifications to it, it's stable. If it got passed into you,
got it.
Stable.
You mean I need to make sure that this object is never escaped out of this method, and then I need to check all uses of this one and make sure that it's only right once.
Right. You're basically doing a wimpy escape analysis. You can make it really trivial if you're looking at a common pattern and you only want to handle the common pattern. The common pattern is I made a new string and I did some concatenation or whatever the hell I'm doing with it. I did a stupid thing, a substring, and I'm done. Then you can do a trivial escape analysis that says, for all uses of the original new, inspect if there is anyone that does a return or store the value or passes an arg to a call or whatever, name your set of things, then you fail and you're not stable. Boom, done. But you cannot just take a load of a pointer and declare it stable. That's a bug.
Remind
you could
be a little bit careful. You have to know what the implementation of some of the string methods might be. Case in point, in OpenJ9's Java implementation, the .equals method might change the string behind the array behind you. So I found another one that's the same. We'll reuse that one.
If it's written in Java, then the C2 would inline it, and then it's so the JIT can get a chance to say it has the entire scope. Does the lifetime check and you're done. If it's a primitive for equals, then you have to know the primitive semantics, and that would be a case where you would declare, not equals done or not stable done.
Yeah, I got it. I will try that. I think that is possible to write it. Just check the non-escape objects and try to because there are some kind of preconditions. This object is array. This object never escaped. Then I just iterate all uses and track them down, and I don't think it's very hard. And I can try that.
Yeah, you don't need to know that it hasn't escaped. If you iterate all users, that's your escape right there. That is the escape, or the escape test.
Yeah, I can make use of the results from the connection graph because C2 return those information after the escape analysis.
Well, there's a separate escape analysis pass somebody added long after I left. I did all this stuff sort of incrementally on the spot by typically doing a for all users.
Okay.
Or make arrays immutable.
Now it's Java. I can't do that.
Oh.
Yeah, that's very annoying because Java cannot. There's a new GEP to propose a concept called frozen array. Yeah. So before that, there's no effective way to figure out that this array is mutable or not.
There are no const arrays in Java. Suck it up. That's another place where I could claim you could do better than Java. But fine.
Once we know that the array is mutable, then we can do a lot of optimization based on that.
Exactly. This is Cameron's point, which I totally agree with. Java had to do it the hard way because they had to learn that lesson. And I'll claim everyone else had to learn it when Java failed it. That's fine.
Yeah, because if you take a look at the Grava library, there are many immutable data structure like immutable array list or a mutable whatever. Under the hook, those are like arrays. So, But if there's no effective way to declare immutable array, then compiler has no idea about them. So even though your class name is immutable array list, but compiler has no idea about them. So compiler has to be very conservative, you know.
Right. The class name's no good. Obviously, if I'm a hacker trying to break your system, I'll just make my class called immutable and then mutate the hell out of it. So you just go on the class name. You gotta validate that it's correct. And yes. I claim there's a straightforward, trivial validation technique in C2 that just says for all uses, if all the uses same.
Okay, let me search first. Maybe there's an existing code to do this kind of thing. Thank you.
Yep. All right. Anyone else? We good till next week? All right. It was a good, fun conversation here. We'll give it a wrap till we meet again.
Bye, everybody.
See you guys.